All right, go away. Here's what you can do is you can do all kinds of different tests. Just find some of your data sets. So in my instance, I have squamous cell versus normal, or I have squamous cell and adenocarcinoma. What I can do is I can test to see what genes are different between that type of cancer. And here's how we do that. We need to go to stats. We go to this ANOVA function, analysis of variance. Basically what this is doing is it's measuring groups of things and determine whether the distribution around the mean is the same. If it's different, then that means it's probably a different group, and therefore you have a difference. Then you get a p-value. Okay, so we can hit ANOVA, and this is where you can test anything you want, guys. And this is really cool. Like we can do characteristics. Oh wait, that's not that one. Let's do histology. We can even do race. You could see what genes are Oh, let's do sex. That'll be awesome. So contrast, I'll put the males up here and the females down here. Then I hit add contrast. Okay. Oh, wait a minute. I forgot to tell it something. I'm going to delete that contrast first. So my data is it's just in normal. I want to tell it that it's not log 2. If all your numbers fall between about 2 and 16, you have log 2, and then you want to hit this yes. If you've got numbers in the thousands, you want to hit no. Everybody follow that?
Mm-hmm. So, between what and what?
Like if your numbers for your genes, so if I wish I could look back here. But if your numbers for the genes, your levels for your genes are all fall between like, say around 2 and 16, that means that the software already took the log 2 of those numbers. If you're getting genes like, anywhere from 10 to 1,000, that means there was no log correction to it. So you want to tell it no. And then again, we can do, so I'm going to put the males here. This is what I want to compare. Do the females, and then I hit add contrast. What I can also do is get the average values for the genes that are different for these two conditions. So here I did the add contrast. Here let's go to add combinations. Oh wait, don't go to add combination, never mind. So hit OK, whatever comparison you want to do. And then here in the advanced, then I can put the mean values for each category. Oop. Where is it? Oh, there it is. Okay. So I can say I want the mean value. This is the characteristic I want. And then I can say all levels, so both male and female. And then you have to hit add. Okay? I hit OK. And let's rock and roll. Let's see what genes show up. Let's see, what is this? Well, let's see. So here's the X silencing gene right here. And we can actually, remember we can do that annotation. On mine, I think I have chromosome number. Let me make sure. Probe chromosome orientation. Wait. Yeah, let's do that. Let me hit OK. Oh, wait a minute. Sorry. Insert annotation. That's just telling me the positive or negative strand. There it is. Chromosome. Hit OK. Look, Y, X, Y, X. This stuff works, guys. The 2, what is this? Oh, chromosome 2, yeah. So this is chromosome 2. But see, this works. I mean, you can do things like this to kind of test to make sure, that your system is, you've got everything labeled correctly. If you test against males and females and you don't see any difference, then something went wrong. BT, this is a great test for you. So here's what I kind of want you to do tonight. is basically, just start playing with the data. Do all kinds. Remember, make a copy of the data set. Make a copy of the data set. If you have to, start over tonight.
I will.
Okay, start over. You know how to do it. I've posted all this stuff on our Google Plus site. You get lost at some point, just go to the Google Plus page, find that day's lecture, and just watch it again if you forget how to do this. But go around. Here's what I want you to do until Thursday. So we're going to meet Thursday again, okay? Until Thursday, I want you to come and just start playing around with your data set. Do some of this. Look up this gene. What does this gene do? You can Google it. That's as simple as it gets. Basically just get yourself familiar with the data set. And again, this stats ANOVA is good for comparing two different things. Correlative, many to one, is when you want to correlate, when you have a continuous variable and not discrete classes. You can use this function to find things related to that. If you want to find things that are different between two different things, ANOVA. If you want to find many to one, correlate to something, a continuous variable, then use many to one under correlative. Okay.